in the topic of work, energy and power. You are already familiar with the details of this topic, so we will do this. Question. So as you know that in the work, energy and power, work done by the backward forces, this is equal to change in kinetic energy plus change in potential energy, gravitational potential energy, and work done by the work done by any of the force is always equal to force times the distance. And delta KE is the change in kinetic energy, which will be half m into V final minus V initial square, right? And change in potential energy will be mg into height final minus height of the object initial from some zero level. And we also know that the power is equal to the driving force multiplied by the speed, and power is also equal to the work done by the driving force divided by the time taken. This last formula can also be applied for the work done by the driving force when the force is not constant. So this is valid for that case also, when force of driving is not constant. So this is a summary of the situation. Now in this question, if you see June 2009, question number 5, a cyclist and his machine has a total mass of 80 kilogram. So the cyclist starts from rest at the top A. So here is the cyclist. So this is the cyclist and the bicycle. So here the speed is 0 meters per second. Straight path AB and free wheels moves without pedaling and braking. Without pedaling and braking means that the driving force is 0, no forward force. Okay. There is a weight component, but not the driving force. So from to the path B, down to the path B. At B, the speed is already written here, it is 9 meters per second. The path AB is inclined at 2.6 degree to the horizontal and the length is 250 meters. So both information are shown in the diagram. Okay, so this is 2.6 degrees. Okay, so the question is regarding to the situation. Is the question here. This is a question. Given that the cyclist passes through B with the speed 9 meters per second, find the gain in the kinetic energy and the loss in the potential energy of the cyclist and his machine. Cyclist and machine means that we will take the mass as 80 kilograms. So we have to find the gain in the kinetic energy, which is simply, we'll find delta KE. And then if it is positive, it means it is gain, and if it is negative, then it will be loss. So delta KE is equal to half m into V square minus U square, where U is equal to 0 and V is equal to 9. Okay, so it means it is half into 80 into 9 square minus 0 square. So that will become 40 times 81, which if we use the calculator, it is 40 times 81, 3240. So this is positive, so it means this is the gain in kinetic energy. Okay. And then it is also asked that what is the loss in the kinetic energy, potential energy. So again we will find delta PE, so change in the potential energy. If we get negative, it means it is a loss. If it is positive, then it means a gain. So it is half, it is mgh mg into height final. Height final means that finally it is at the point B. So it means height of B minus height of the initial point, which is A, according to this context. So see that initially the object, the cyclists were at this height. This is the height, initial height. So this height is 250 sine 2.6. So it is 250 sine 2.6. So it's 0.6. Okay, this is the height of A. And the height of B we take 0 because the ground level will take as the 0 level, which means that the height will be taken from this level BCD. So it means mass is 80. So this will become 80 times G we always take as 10. Height final is 0. Height initial is 250 sine 2.6 degree. Now using calculator we will find this value. Make sure your calculator is in degrees. So it means it is 18 times 100 times 250 sine 2.6, and we'll get a negative sign with this because it's 0 minus. So it is 9072.597 and so on. So to three significant figures it will be negative 9070, because this 2 will become 0 if we are doing to 3SF. So it means it's a loss in EE, and this loss is 9070 joule. So this is the second answer. Okay, so then hence the third part of the question, and hence find the work done against the resistive force. Hence means that using the work energy method, because we already have found these two quantities, so it means that using the work energy. If we don't use the work energy, then it means there is chances of losing the marks. So overall it's only 3 marks question. So we know that since the resistive force is not given in the question statement, so it means only by using work energy equation we can do it. So work energy equation, as you know, it is work done by the forward force minus the work done against the backward forces. That is equal to change in KE plus change in PE. So since there is no forward force, if you see the diagram, there is no forward force. So it means we take this work done 0, and this work done we have to find basically. So work done against the resistive forces, that is equal to change in kinetic energy, which is this 3240, and then delta P is negative, so it is negative 9072.6. We are using more decimals to get the answer correct to 3 significant figures. So when we subtract these two, so we got minus work done against the resistance is minus 5832.597. So minus minus is cancelled, so the work done against the resistance is equal to 5830 to 3 significant figures. Okay, so this is all 3 answers we gave to 3 significant figures. So this is the first answer, this is the second loss in potential energy, and this is the work done against resistive forces. So all this is part 1 of the question. Okay, so it has another part. So the cyclist continues here I will paste the question. Second part, before the second part there is some description. It means in addition to the previous information, this is the new information. That cyclist continues to freewheel along the horizontal path, straight path BD until he reaches the point C. So if I copy the diagram here, so we need only the rest of the diagram, not the point A, like this. Okay, so now the motion from B to C and then C to D. All this is freewheeling. At C the speed is 5, at B the speed is 9 meters per second. So the resistance to the motion is constant and it's the same on BD as on AB. So the previous resistance, we don't know the resistance, but we know the work done by against the resistance before. So find the value of D. D is actually the distance between point B and C. Okay, so we will again apply work energy equation from B to C. From B to C, applying the work energy equation. So it means that the work done by the driving force, it is freewheeling, so it's 0, minus the work done against resistance. Remember that will be different now. So we need to find first the resistive force. So force of resistance first we'll find. We already know that the work done against resistance is equal to 5832.5. We can take 0.6, this one, 5832.59, so 0.6. This is the work done against resistance while covering a distance of 250 meters, right? So from A to B, 250 meters are taken. And this is the work done against that from A to B, which is 250 meters. Okay, so work done is resistive force multiplied by the distance moved. So that is equal to this value. So it means that the resistive force will be 5832.6 divided by 250. We will not divide this, we will keep the same value there so that we will get more accurate answer. And this is equal, this is the work done, sorry, this is the force. This is also a mistake which usually the students do. So this is the force only. So this in work energy equation we have to put in the work done. So times the distance moved. So times D. D is the distance moved from B to C. So that is equal to change in kinetic plus change in potential. Now change in kinetic will be half into M. M was 80. So M mass was 80 kg. So 80 times V final 5 square minus initial 9 square and then plus mgh, final mass tension. B and C are at the horizontal level, so that means change in the potential energy will be 0. So we know that delta PE is 0 when the object is going horizontally. So the whole thing has only one unknown, which is D. So from here we can find the value of D. So when we simplify the left and right hand side, so it will be negative because 9 is bigger than 5. Okay. So we got it minus 2240, and that is equal to this value. So that means D will be equal to this value divided by negative 5832.6 over 250. Okay, so now minus minus is cancelled, so we will have, after doing the calculations, negative is cancelled, so it is 96.012 and more decimals. So it means to three significant figures it is 96.0. So this is the value of D. D meter is covered, so meter we don't need to write here. So see, this is the answer of the second part of the question. So till now we have done 3 marks for this and 3 marks for the first part, so 6 marks. Still, I think there is one more part of the question. So it is this one. Now the motion will be from C onward. So the cyclists start to pedal at C. Again, we will see the previous part of the motion, this diagram. I will copy here. Okay, so now the motion is from C onward. So from here onward. So now he is begin to pedal, which means he is giving the driving force. Motion is horizontal, so delta PE will be 0. But maybe we don't need this information here. So see, we're generating 425 watts of power. So it means power is given, power is equal to 425 watts. Find the acceleration of the cyclist immediately after passing through C, which means passing through C means when it was at C, so at that moment when it goes forward. So this is the cyclist, mass is 80 kg. So we have to find the acceleration at this, because due to the pedaling the acceleration will occur. So acceleration we have to find. So we can find the acceleration only through the Newton's second law, which is forward force minus the backward force is equal to ma. So P is equal to 420. So first we will find the driving force because the power is given. So we know that the speed at C, speed V is equal to 5 meters per second. So it means using P is equal to force of driving times the speed. So 425 is equal to driving force multiplied by 5. So this is giving us driving force equal to 425 over 5, which is an exact answer. So that's why we'll do this calculation. If the result is not accurate, not exact, so then better to keep it in fraction. Okay, so now we got the driving force, and throughout we have the same resistance, right? And that resistance will be this one, which is this 5832.6 over 250. So just copying this information on the lower part, part 3. So this is, and now we will apply Newton's second law. So by Newton's second law of motion, we know that complete version of the law is forward force minus backward force is equal to ma, and the forward force is the driving force, backward is the force of resistance, and that is equal to, or that is equal to ma. So driving force is 85 and the resistive force which we have here is this one. So just I will copy this value there. Sorry. So this value minus this value is equal to mass is 80 times A. So this will give us A is equal to and the whole thing divided by 80, the mass. So we got the acceleration equal to 0.77087, which we round to 3SF. So 3771 meters per second square. Okay, so this is the result. See, that is it the same which we written here? Yeah, so 0.77 meter per second square. Yes, meters per second square. So this is the question. Okay, so it is 3 marks, so total question is 9 marks question. Question number 5 of June 2009. So it covers all potential energy, kinetic energy changes, work energy equation, and then the power formula also here, all are used here. Inclined motion as well as the horizontal motion, all are here. Okay, then we can do one more question, short one, which is June 2010. Question number 1, this one. Okay, so here a car of mass 1150 kilograms travel up a hill inclined at 1.2 degree to the horizontal. So we will draw the situation. So this is an inclined surface. Better to make a smaller slope because the angle is very small. So 1.2 degree to the horizontal. So car is traveling up to the hill, so it's going up. So let's say here is the car. This is the car going upwards, whose mass is 1150 kilograms. The resistance to the motion of the car is 975 Newton. So here backwards we can show the resistive force, which is 1150 Newton. Find the acceleration of the car at the instant when it is moving at a speed of 16 meters per second. So let's say here it is going with a speed of 16 meters per second, and we need to find the acceleration. So acceleration A we have to find. So as I told before that usually this kind of questions are asked, that what is the acceleration when the speed is this and the power is given, and what is the speed when the acceleration is this and the power is given. So we know that the power is already given, which is 35 kilowatt. So 35 kilowatt means 35,000 watts, because kilo means 1000. And in SI system of unit, power is in watt. So basically the question is we have to find the acceleration when the speed is 16 meters per second. And for the acceleration, we use the Newton's second law, and for the Newton's second law, we need the forward force. Obviously, it is going upward with an acceleration, so there must be some forward force here. So let's say that is the driving force provided by the engine, right? So to find the driving force, we will first use the power formula. So power is equal to force of driving times the speed at that particular instant. So power 3500, that is equal to the driving force times the speed. Speed is given 16. So this is giving us that the driving force is equal to 35,000. It will also be exact because we are dividing by 16. So 2187.5. Remember, if it is not coming at an exact long decimal chain, so better to write in fraction form. Usually when we divide by 3 or by 7, then we have non-exact value. Okay, so this is the driving force. And now, other than the resistive force of 1150, there will also be the weight component. In work energy equation, we don't take the weight or weights component, but in Newton's second law, we also consider the weight component. So here I will show another force in the backward direction, which is W sine theta. We know that on the inclined plane, if some object is placed, so it has two components of the weight. One acts down the plane, which is W sine of the angle which the surface is making with the horizontal, and the other component is W cosine theta, right? But W cosine theta we are not using here. We are only using those forces which are acting parallel to the plane. So now the question is about to finish. So using Newton's second law, second law of motion. So complete version, forward force minus the backward force is equal to ma. Forward force is Ft, which is 2187.5, minus the backward force is two forces backward, so we can put both negative, or in the bracket you can write sum of those two. So 1150 and minus weight, which is mass is 1150. Here in the question statement, the 1150 is the mass, and the resistive force is not 1150. It is 975, right? So it's 975 Newton. So in the first part we didn't use this. It's not used. So now we will use it. So it is not this. It's 975. Okay. So, and then the weight component will be mg sine theta, which is 1150 is the mass, and if you put one more zero, which is multiplied by 10, and sine of the angle 1.2 degree, and that is equal to the mass 1150 times a. So through this we can find the acceleration. So using the calculator, the 187.5 minus 975 minus 11500 sine of 1.2, and this whole thing divided by 1150. So we get A is equal to 0.84492 and so on. So when we round it to three significant figures, so it is 0.845 to three significant figures. So this is the result, that the acceleration is 0.845. So see that this question is 4 marks. So and this is the working for this question.